In this video clip, I want to quickly derive the pH of a weak acid. That's something that students sometimes find a little bit tricky, this concept. So let's just simply say we start with an acid and we put that in water. So that is our acid, the starting concentration. And if we don't have anything there, that is our starting concentration. But as soon as we add water, something will then happen. And obviously our acid will dissociate into H3O plus A minus, and A minus is the conjugate base to the acid HA. So when we wait long enough, we will get our equilibrium established, and we can write the equilibrium, Ka with the equilibrium constant, equals H3O plus. And we probably should say that this is the proton concentration at the equilibrium, and I indicate that with an EQ subscript, times A minus equilibrium subscript divided by what is left of the acid. And again, that is our acid concentration at the equilibrium. Now note, the equilibrium acid concentration is not identical to the starting concentration because the acid has dissociated into H3O plus and A minus. And from our stoichiometry of this equation here, we can also say that for each molecule of proton, we get the same amount of base ions. So naturally, we do not know what this equilibrium concentration of the acid is. We also don't usually know what this proton concentration is, but we know that the proton concentration is the same as the base concentration. So what we can write is, let's just simply say we set H3O plus, we treat this as X, as an unknown, and we can write Ka equals X times, well, we know that the base concentration, this one here, is exactly the same, so we can write X squared divided by, and we know that the HA equilibrium, the acid equilibrium concentration, is really HA, our start concentration that we had, minus X. That's basically everything that is left over after the acid has dissociated and produced the proton and the corresponding base. So what we have here is really a quadratic equation, and naturally we would try to solve for X. So what is X? What is our proton concentration in this case? Because we use the proton concentration in order to calculate pH. We could use a quadratic equation, but sometimes it is just easier to make the assumption, especially when it is a very weak acid. We can say with a degree of certainty, in the case of a very weak acid, we can say our starting concentration minus X is very close to actually the starting concentration. It's not the same because the acid loses a few protons, so the concentration of the starting concentration will go down, but if the acid is very weak, the loss is not very strong. So with that we can write Ka equals X squared divided by HA, our acid, the starting concentration. And that is something that we know, and usually we know Ka. So let's solve this for x. So we have x squared equals our Ka times our starting concentration of the acid. And what we can do now is we know that the pH is defined as the negative log of a proton concentration. So what we can do is we can take both sides negative log. And so we get negative log x squared equals negative log Ka plus negative log of our acid concentration. That's the starting concentration. Now, following the rules of logarithm, we get 2 times negative log proton concentration, that was our x, equals minus log Ka. We know what this is. This is pKa. Plus minus log, so we can write this as log of the acid concentration. That's the starting concentration. And we can say 2 times, now we know what minus log proton concentration is, that is pH. 2 pH equals pKa minus log of the acid. Or we can just simply say we divide both sides of the equation by 2. So we get pH equals 1/2 of pKa minus log of the acid concentration. And this time I write it out as acid. And that is our starting concentration of the acid. So that is an equation that roughly allows us to calculate the pH of a weak acid. Now this equation only works with the assumption that the acid does not dissociate totally, and that the dissociation of the acid is actually fairly small. If we are working with a strong acid, we cannot use this equation because this assumption here is violated. So with a strong acid, we would use the pH equals minus log of the acid concentration. If acid is very strong, and we usually would say we consider an acid as strong if the pKa is smaller than, say, probably 1 or 2. If the pKa is if the pKa is above 2, we would use the equation for a weak acid. If the pKa is smaller than 2, roughly 2, we would use the equation for a strong acid. I hope this makes sense, and thank you very much for watching.